This problem is asking us to find the displacement of a simple harmonic motion for the point where the energy is half kinetic and half potential. So half of the total energy is kinetic and half of the total energy is potential. Now recall that kinetic energy is related to the motion of an object, while potential energy is related to an object's position. Because this problem is asking about the displacement of the object during the oscillation, so because potential energy is more relevant to position, we're going to start by clarifying that the potential energy, E sub potential, is equal to half of the total energy. So both potential energy and total energy for harmonic motion, both of those energies can be rewritten as equations in terms of position. So I'm going to expand both of these E terms out a bit. So recall that for elastic potential energy is equal to 1/2 multiplied by k multiplied by x squared, and this is equal to 1/2 of the total energy, which, again, recall that for simple harmonic motion, total energy can be rewritten as 1/2 times k times the square of the amplitude of the oscillation. And of course, recall that k refers to the elastic constant, or the spring constant, of whatever is causing the harmonic motion. So algebraically, we can see that the two k terms will cancel out, and one of the 1/2 terms will cancel out as well. So we're left with x squared equals a squared divided by 2. And to solve for x, we're just going to take the square root of both sides of the equation. So taking the square root of x and the square root of a squared divided by 2. So we can see that a is equal to a divided by the square root of 2. And since we took a square root, technically the output could either be positive or negative, so I'm going to add a plus or minus sign in front of it. Alternatively, this could be rewritten as plus or minus 0.707 times the amplitude, as 0.707 is approximately what 1 divided by radical 2 is equal to. Now the problem doesn't give us any information about what this amplitude is. The problem actually doesn't give us any given values, so really we can stop there, and that is the best we can get as an answer to this problem. And that is it for this problem. I hope this video helped you out. If it did, please consider subscribing, as that'll help me out in making more videos like this. And if you have any requests or questions, leave a comment down below, and I'll do my best to help you out as best as I can. That's all for now, and I hope you have a lovely day. Bye-bye.